Welcome to the Principles of Compiler Design video series, and here today we are going to see on about the NFA, that is nothing but your non-deterministic finite automata. So let's see the formal definition of the non-deterministic finite automata and see an example how the NFA is constructed from the regular expression using the Thompson's construction algorithm. Officially or the formally, the NFA can be defined as it is similar to that of the DFA, but it consists of the same 5 attributes as that of the finite automata, which includes the set of states, input symbol, start state, final state, and the transitions. But there is a one difference where the NFA consists of multiple transitions from the same input, and it will include the epsilon transitions, or otherwise called as the empty transitions. And also there is a different procedures in order to convert from NFA to DFA. The DFA can be constructed either directly from regular expression or it can be converted from NFA. So this NFA consists of similar to the finite automata and as the several states. So this is the formal definition, which includes finite set of states, input alphabet, transition function. Here we have 2 power transition functions on same input symbol, start state and set of accepting states. Let's go into an example. Today we are going to deal the construction of NFA using Thompson's construction algorithm in the principles of compiler design. So in the previous video we have seen the introduction to the NFA, DFA and how it has been framed and with some examples. And now we are going to the official construction of the NFA using Thompson's construction algorithm. So let's go into the algorithm. Whenever there is an input symbol, for example A, the Thompson's construction algorithm states that the A transition should take from one state to another state. So this is the input symbol A, which transits from one state to other state. And there is another transition called epsilon or the empty transition, which is represented as for state 1. On epsilon transition it goes to another state. Then third condition, if we have a concatenation from A to B, the state is termed as the output state of A becomes the input state of B. The input state of B will be joined with the A. So A here, the output state of A is joined as input state to B, and this becomes the final state. And now we are going to take with the next expression as A slash B, means that A or B. So here the construction algorithm says that join the A expression and B expression transitions with epsilon at both the sides. This leads to the final state. Then comes A star. So A star indicates 0 or more occurrence of A. So as usual we are going to take the A automata, and now we are going to introduce one state before the starting state, one state after the ending state. These states are marked as epsilon. From the starting towards the ending state, perform the epsilon transition, and last before to first after introduce the epsilon. So these are all the rules stated for the NFA construction algorithm. So now let's take an example of A slash B the whole star, AB as the regular expression, and let us construct the NFA based on the given algorithm. So let's start for A and B. So for A, the NFA becomes this, and for B, this is the NFA. Now combining A or B, it is given as epsilon transition for A and B joined with epsilon transition to the final intermediate final state. Now next one, A slash B the whole star. We are going to take the same A slash B. Then for this final state and starting state, include one state before and after, which is marked to be epsilon. Now, from the starting state towards the final state, mark the epsilon, then last before to first after epsilon. Now, there is a concatenation operator which is to be taken with the a/b the whole star with a. So, the final state of the previous expression becomes the starting state of the next one, which should be combined for a. Next, again we have another one B symbol, which is on concatenation. So again it reads. So this is called as the final state because there are no more symbols here. So this becomes the starting state. Now let us mark the state numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a final automata constructed through the Thompson's construction algorithm for the given regular expression a/b the whole star a.